Hello, my name is Jompon Foowongsit. My student number is 6410550x63 from the section 450. And here is my student card. So the project in the mini project, like mini project 2, in the instruction, teacher gave us like three circuit that we want to do. So I show the GCD circuit here. When I search the GCD is a greatest common divisor. In Thai is a Holamor. So I go search in the internet and found that the easiest way to find a Euclid and don't have that much complicated solution is Euclid methods. But in the Euclid method, we use the Euclid that's about the minus, not devices. So Euclid method for computing greatest common divisor for two positive integer consists of replacing the larger number by the difference of the number and repeating it until two numbers are equal or equal 1. For example, number 7 and 3, find the GCD by 7 minus 3 equal 4, and 4 is not equal 7 and 3, right? So we have to find we have to get the answer that may equal to 1. So we bring 4 back and minus with 3. 4 minus 3 equal 1. So the GCD is 1. And for example, and another example is like 8 and 4, right? So we have in our way like that the GCD is going to be 4. So how to find it? We bring 8 minus 4 is equal 4. So it's equal to the number that we find the GCD. So the GCD is 4. And for another example is like 8 and 6. Oh no, it's too easy. Maybe 7 and 21. So 21 minus 7 is 21 minus 7 is a 14, right? And 14 is not equal to 7 and 21. So we keep doing it like, because we got a 14 minus 7 equal to 7. So 7 is equal to the 7 that we have to find the GCD. So the answer is 7. That is GCD. So back to our circuit. Here we have a big main circuit, right? I break the circuit to the 3 groups. Like here is the input. We have a 3 resetting second, 3 second resetting, and another one is the 7 segment, which has a 744A circuit in it to display as the number of input and output. And this big one is a Euclid circuit, like a calculator for in the circuit to find the GCD number. So first 3 second, in the 3 second I employ a register in our circuit operating in sync with a clock. Here clock in sync with the clock at the frequency at 4 Hz or 2 Hz, because I choose 4 Hz because it's faster. And we choose 6 state because one state give us a 0.5 second. So 6 state x with 0.5, we have a 3 second circuit resetting. And following this, shift register with 6 state is authorized to create a blink effect here. After we have a shift register, we send it to here, signaling the initiation of the resetting process. Subsequently, the 74161 counter is integrated into the circuit to ensure that the reset circuit here after the 3 seconds for added protection against the unintentional addition via the reset button. The first shifter is connected to the clear here to clearing to clear input of the 7161 counters to facilitate this. And inverter is introduced to convert the active high signal to an active low signal. You can hear high signal to low signal. For clearing purpose, additional to NAND gate here is incorporated to act as a safeguard, treating the inadvertent introduction of more number into the circuit. So let me explain more. So if we start the operate, like we have the shift resetting, we have shift register, and we shifting. So I don't want to circuit think that here does mean the adding more number. We just want to bring out the 3 second only. So we have a NAND gate to here. If after we, so like if for example I put number here, for example, and I don't think that I don't want the circuit think that I put number here to make more number. So I have a NAND gate to protect us from the circuit that thinking that we add more number. Let me show you here. And I put 1, so we start resetting 1 like shift register, and here they send 1 0 1 0. So when 1 0 1 0 six times, so when the 1 0 send out, they got inverted to 1, so the T flip-flop send out the signal that 1 0 1 0 1 0 3 times. That is how we made the 3 second circuit. And next one is a 7448 IC, which means a 7 segment display. We can find the IC that have the circuit ready for use, but when I search in the Google and download it doesn't look good, and I don't understand the circuit. So I study the IC circuit and make it, like modify it modify it in with my knowledge or with my understanding. I keep doing this like almost half a day, like until I got this here, like 1 2 3 4 5 6 7 and 8 here, 9 here. When I have this 7448 IC like segment, we go to the Euclid circuit. So Euclid circuit is about the like the calculation that minus, like a minus b until we got the answer here. Let me show you. So I have 4 inputs, and with the first 2 represent initial set of digits, and the 2 for the second set. Like it mean A and B, like A and B 2 numbers with 2 digits, like 10 12 10 12 1 2 3 separated. Then we send the pin that input number to the multiplexer, and multiplexer send to the register, like which is the flip-flop. So that we invert the number, invert the output from number B to the carry in carry out, and we send another B number to the carry in carry out and calculate with the A, like +1 -1 +1 -1, and after that we send the output from the carry in carry out to the 74283 IC. It's a additional IC, and before we do that, we check that number out from the carry in carry out is not are not 10 and 12, which is 1 0 1 1 and 1 1 0 1 1 0 0. After that, we send to the IC, and we send the output from IC to the multiplexer to show us the answer. But here is the answer, but this one is for that multiplexer that show to check us that the answer is not negative. For example, someone like to, for example, someone put the number in the circuit. We use a minus b, right? Not b minus a. So in a minus b, sometimes the user put input that a is less than b. For example, number a is 4, number b is 7. So a minus 7 equal minus 3, like, and we cannot calculate. We cannot show the answer. So this multiplexer is to check that if negative, we send back to like calculating again to make sure that our answer is positive. And back to the main, we combine 3 circuits into one. Like here is a button that we input the number a, b, if you can see, and we have to put the 3-second resetting to operate that when we hold down the button, the whole circuit will reset. And after that, we send the the output from the 3-second resetting to the display, 7-segment display here, to show us the input, the number of our input. But why we inputting the number? So the output go here to start the calculating with the Euclid circuit. So when we calculated that, but we calculate by the time, by the tick time. Here you can see tick time, and the bottom is here is for the start calculating. After that, when we got the answer, you can see that the answer the multiplexer will show to here the answer. You can see here answer. And in the main circuit, we have to connect more the register like D flip-flop and T flip-flop to make the display that tick with the clock. And here is the button that clear. So we want to clear all the circuit with this button. I will show you. The problem from this circuit is when we input the number while the clock is ticking, it sometimes have the answer here. You can see that it show us the 999. So they think that when we input fast, like input too fast, the circuit will think that we using the 3-second holding the button. So we didn't mean to hold the button. So I will take this off and start putting number, for example 4 and maybe 5. So I want the GCD to be 1, right? We know that the GCD is 1. So tick enable, and I press here. You can see here the answer is 1, as you see. Then okay, if you want to resetting, you hold here is resetting. Okay, and if we put the number but we want to clear all, here we clear. Okay, here is my device using our combination. So here's we have a pin multiplexer adder, lot of the devices. So this devices table is not only for the main circuit, it's all circuit that from the 744A, from the 3-second resetting, from the Euclid circuit. That is my GCD calculator. Thank you.